Next we go look into the another problem. Using auxiliary equation, find the general solution of d square plus 4dd dash minus 5d dash square into z is equal to e power 2x minus y plus sine of x minus 2y. So consider as a given equation. So now we are going to write the auxiliary equation. So auxiliary equation I already explained. Replace d by m, d dash by 1. So can be written as m square plus 4m minus 5 equal to 0. So solve this quadratic equation. We get the two roots for m. So now we are going to write the complementary function. So CF is equal to f1 of y plus x plus f2 of y minus 5x. So here two particular integral is given. So we are going to find the particular integral 1. So 1 by d square plus 4 dd dash minus 5 d dash square into e power 2x minus y. So the same procedure we did in the ordinary differential equation. Just to replace d by what is the coefficient of x having 2. So just to replace, and the same way what is the coefficient of y is having minus 1. That we have to replace by d dash. So we get the 2 the whole square plus 4 into 2 minus 1 minus 5 into minus 1 the whole square. So can be written as 4 minus 8 then minus 5 into e power 2x minus y. So we get the 1 by minus 9 into e power 2x minus y. So next we are going to see the another PI. 1 by d square plus 4 dd dash minus 5 d dash square into sine of x minus 2y. So here also replace d square by minus 1, dd dash by 2, then d dash square by minus 4. So d square by minus 1, so minus 1, dd dash by 2. So 4 2s are 8 minus 5 into minus 4 you get the plus 20 sine of x minus 2y. So the value is 1 by 27 into sine of x minus 2y. Therefore, the solution is equal to z is equal to complementary function plus particular integral. Next, we go to the another problem. Dou solve dou square z by dou x square plus dou square z by dou x dou y minus 6 into dou square z by dou y square is equal to y cos x. So consider as a given equation. Now we are going to write the auxiliary equation m square plus m minus 6 equal to 0. So solve this equation, we get m is equal to 2 comma minus 3. Then write the complementary function f1 of y plus 2x plus f2 of y minus 3x. So now we are going to find the particular integral. So here we have the another type. So previously we saw that e power and sine. Here multiple of y into cos x is having. So now we have to split this denominator according to this value of m. We can write d plus 2d dash d minus 3d dash. Split and write. Then now we have to replace instead of this y as c minus 3x. I am considering this d minus 3d dash. So here we have to replace y as c minus 3x into cos x dx. So this one you have to integrate by using the integration by parts formula u v1. So integration of cos is sine plus cos 3x cos x into differentiation of 3x is minus 3 will get. So I have to write the plus 3. Then after this one finally replace this y sin x plus 3 cos x. Again for this term you have to put the integral of c plus 2x. So here we have a d minus 3 dash or can written as c minus 3x. Here we have a d plus 2d dash is having. So can be written as c plus 2x into sin x plus 3 cos x into dx. So how to these two terms you have to integrate by using integration by parts. Then this one you have to use usual integration. We get the sin x. Then now replace c plus 2x as y. So minus y cos x plus 5 sin x. Therefore the solution is z is equal to f1 of y plus 2x plus f2 of y minus 3x minus y cos x plus 5 sin x. That's all. So up to this homogeneous partial differential equation is over. So now we are going to the non-homogeneous partial differential equation. So non-homogeneous partial differential equation is nothing but in which the order of the derivative is not same is called the non-homogeneous partial differential equation. So the homogeneous, the order of the derivatives is same. Here the order of the derivatives is not same. So here we have a two cases is having. So finding the complementary function. If d minus m1 d dash minus alpha 1 d minus m2 d dash minus alpha 2 is equal to f of x comma y, then complementary function z is equal to e power alpha 1x f1 of y plus mx m1x plus e power alpha 2x f2 of y plus m2x. Next case 2, if you have the repeated value, that is a whole square if we got, we can write e power alpha x into f1 of y plus mx plus x into e power alpha x f2 of y plus mx. So next we are going to look into the problem. So here the complementary function is different for this non-homogeneous, but particular integral is same for what we did in the homogeneous, the same is for non-homogeneous also. So now consider the left hand side of the given differential equation. So here see, look at here, d square, here the power is 2, the order of derivative is 2, here the order of derivative 2, here also the order of derivative 2. So here order of derivative is 1, here also order of the derivative is 1. For all the terms the order of derivatives is not same. So therefore this comes under the non-homogeneous type. So now we have to split this term as d minus m1 d dash minus alpha 1 like that form we have to split. So for that one we have to consider this given equation as a quadratic equation in capital D. So we know the finding the quadratic equation d is equal to minus b plus or minus root of b square minus 4ac by 2a. So that form we have to do this one. A is consider here find out a is equal to 2, b is equal to minus d dash minus 6, c is equal to minus d dash square into 3d dash. So substitute here, we find the value finally 4d dash minus 12 by 4 minus 2d dash by 4. So divide by 4, we'll get the d dash minus 3 into d dash by 2. So substitute here m1 is equal to, from this we can find m1 is equal to 1, alpha 1 is equal to minus 3, m2 is equal to minus 1 by 2, alpha value is 0. Therefore, complementary function is equal to e power minus 3x f1 of y plus x plus e power 0x f2 of y minus 1 by 2 into x. Then particular integral x into e power y if we have, bring the e power y to front. So no x term is having. So replace d by 0, d plus 0, d dash by d plus 1. So after replacing, we get the result like this. Then use the binomial expansion. So right here, then x plus 5x square by 4, x cube by 3. Then have to